Sarah, which one are we talking about?
Number 9.
Start with number 9?
Yeah.
Oh, God. It's video day next door. It is a little warm in here.
Maybe we should cancel the class.
Little climate wimps. Come on now. Water. Good moves. So number 9. Okay. It's a nice little one to start with. Wow. So this one here, right? X plus 4y. Was it 60? No. Number 9?
Yeah.
9. Okay. Section 9.3. Where are you? 3x plus 5y. X plus 4y equals 8. Okay. I think what I'll do is we'll do this one up on the board, and then I'll actually show you how to put it in the calculator. Calculator. Yeah. How do I convert this into a matrix? Okay, why is this a really nice one? Not just because there's only 2, but there's already a 1 where you want it. We're going to do an example in a bit about if you can't make a 1 and the numbers are gross, is there something else you could do? Yes. I'll show you. How do I? Yeah, I love it. Can you please tell us the reason for dropping? The numbers got gross. Just told they wouldn't get gross. It's always an option. So how do I use that one since it's so nice? Why is it so nice? Yeah, if I multiply this row by -3. So let's just do this more steps than really need. So we'll do 3 row 1. We'll just do that step by itself. -3 row 1. So what do I get when I multiply that by -3? -3, -12, -24, and this guy stays the same. Is he really going to make me walk over there again? All right. So now that we've done that, we of course are going to add the 2 rows. We're going to put the answer. Row 2. Row 2, so I don't lose that 1. There really is still a 1. I can just divide by -3 and recover my 1, right? How are we doing so far? You okay? So -3 3 is 0. -12 and 5 is -24 and 3 is. That's right. And then the top row. All right, let me stop. Please ask me questions right now if you have them. I'm gonna go over there. Sorry. If you haven't done this problem yet, try to get it further. It's actually somebody different today. We'll see. It's a little bit different. I didn't stay long enough to tell. Okay. So how do I write the first row now?
1.
Yeah, go back to this. If you're like, how did I do that? Okay, divide by -3. You know, the only reason I multiplied by -3 is so I kill that 3. I killed it, so now I can go back to the way it was. So what do and if you want to do something, you divide this by -3. 1, 4, 8 comes back. Then what can I do on this row?
Divide by 7.
Divide by -7. See how, when you only have 1 here and this guy, you divide by whatever that is. Because then you got an answer, right? So if I divide the row 2 by -7, I'll get 0, 1, 3. And now is there something there I can use? See, that's really nice. Once you get all the other variables killed, you'll make a 1 here, because you'll divide by, because that's the next step. You want to see what and then I'll have a 1 that I can use. How do I use that 1? Yeah, let me see if I can do the shortcut now. If I do -4 row 2 plus row 1, put the answer, of course, in row 1. -4 times 0 is 0. -4 times 1 is -4. -4 times 3 is -12. So instead of rewriting the row and then bringing it back, I'm just going to put next to it what it would be. So I eliminate this step. That's the first little baby shortcut. So when I add those together, I get 0 and 1 is 1. -4 and 4 is 0. -12 and 8 is -4. 0, 1, 3. So what's the answer? -4 comma 3. X is -4. Y is 3. You could also write it that way if you want to. Let's make the calculator do this thing for us. I'm sorry, I didn't bring them with me because I just got a brain math teacher, but oh well. Just watch. Yeah, just remind you on page 65. Holy crow. There we go. Page 65, they have all the little steps laid out for you. I'm going to try to show it to you real quick. Carrie, can you do your light magic? Thank you. So, the first step is to convert it to a matrix. We've got that right here. Can anybody see a really, really, really useful button? Maybe one that says matrix. Matrix. So it's right above the x to the -1 button. That's your reciprocal button. Oh, okay. If you hit second x to the -1, you'll get to matrix. Now, some of you guys, I don't know, depending on who's used your phone before, maybe all of these are blank. See how I have a little 3 by 4? What does that mean? 3 by 4. That means there's 3 rows, 4 columns. I love it. So I have used this before to create a 3 by 4 matrix. That's all that means. It doesn't matter what it is. Let's all choose A. Now this is where I love the title, names, which means you can't do shit to it. I want to edit. So everybody edit A. If you're playing along with me. If you're not, just watch.
3 by 4 too?
No, how big do I want? 2 by 3. 2 rows, 3 columns. So make it 2 by 3. Smoosh. I had some ugly ass matrix in there. So let's put them in there now. 1, 4, 8, 3, 5, 3. Is everybody cool with that? Everybody see how this works? Go to matrix, edit, and then you can put it in. Now, I haven't used the full, oh shoot, I should probably be recording this. I haven't used the full terminology for what it is we do. This process leads you to what's called reduced Row-Echelon form. Yeah. That's nice. That's the official title of what form that's in. See how the word reduced kind of makes sense in a way? You're getting all the zeros you can, reducing it in a really weird way. Reducing the rows. Okay, reduce Row-Echelon. Okay, well, echelon is tiers. Okay, whatever. Reduced Row-Echelon form. R, R, E, F. Right? Once we got the matrix in there, what do we want to do to it? We don't want the calculator to do what to it? We want the calculator to do math to it. You with me? You're like, sure, Jeff? This calculator is not set up to make matrices easy and quick to get to. So we have to hit second quit to get the hell out of the matrix, right? Take the right pill. Hit second mode to quit. That's a beautiful quit. Get you out of whatever the hell weird thing you're in. Now go back to matrix. Second extra, then I go back to matrix. And now I want to do, like we said, I want to do math to it, right? Somewhere in this list, probably there's an RREF option. If you hit up, you'll get there quicker. Now look at all the stuff you could do. Everybody just calm down. That's all right. So hit row where you just... Oh yeah, I know. They really didn't have somebody check. A friend of mine says, Jeff, you should really help. You should check names because I always come up with the So okay, let's focus on RREF. Hit enter. Now you got to tell it. Now here's how that names thing works. Go back to matrix again. Oh, I know. Go back to matrix. Under names, you select A. This is how you can select a matrix. Edit. You go in and edit it. Names, you can select them. I want to select A. Bam. So I want this sucker to row reduce A. What's up?
Can you go back?
I can totally go back. So let's see. We got our matrix in there, right, with edit. Second quit. Go back to matrix. I want to do some math to it now. I want to do RREF. Then go back to matrix again and tell it which matrix you want to do. I want to do matrix A. And then if you hit enter, holy shit. Yeah, and if you go in and do a 3x4, and then you put all the coefficients in and you do everything we just did, plop, it'll plop it out there for you. Say again?
Is that the answer?
You right? I don't know. No, we both got it wrong. Stupid calculator. Oh, no. Something really neat. I don't know if I showed you guys this before. And how does this relate to anything? Watch. If I hit 0.48, and then I go to math, and the very first thing in math is, do you see how it says to fraction? So if I say take 0.48 to a fraction, it's going to give me a reduced fraction.
How do you get the math button? Oh, hit the math button. Makes sense. Sorry.
That's all right. All right, cool. I like it. What? But watch this. This is really awesome. Just watch. Don't even try to keep up. I'm just going to go in here. If I change one thing in my matrix, I'll bet you anything it's going to make it disgusting. Let's see if that's true. So that's the new answer. Now watch. This kicks so much ass. That's the new answer. I went in and I changed one number. I changed that to a 3, and then the answer is a little bit gross, right? Watch this. Go to math to fraction, and it's going to take... look at that. And then that kicks so much ass. Everywhere it sees a decimal, it says, become a fraction. Anyway, I just want to show you that. It's kind of neat. So if you do have a matrix that has fraction answers, that's how you can kind of bring the fractions in, is you got that little change to fraction button. And you're all like, I wish I knew about that shit back a couple of years ago. But, oh well. There, that's what I just did. Oh, where is it? Math. The very first one.
Yeah, see, I don't have that.
Really? What?
Yeah, mine skipped straight to the decimal.
That's weird as
I
shit.
still don't
Which
have
one do you have? TI what?
E3 plus.
Holy crap. Okay, wait a minute. That's... Oh, no, dude. The math what? There it is.
Oh, you need to literally press the mouse.
Yeah, literally,
And
yes.
then scroll over the mouse.
Oh, I totally didn't capture anything I did I? Oh, forgot to turn that thing around. Okay, so you can check your answers that way for the ones that don't have answers in the back. Right? Okay, any other specific questions?
Do we have to reduce everything to ones and zeros
Yes.
in the matrix?
Yes. Yep. I know. They stop early, don't they? And then they bring it back to equations. My whole point is, if we learn a matrix, why not stay with that form all the way through? I don't like to stop short and go back, because then it's sort of like, well, the matrix didn't really help that much. It only took me part of the way. Do you see what I'm saying? And plus, it's just more practice. Okay, let me show you, like I promised, a matrix that has no ones in it, and we're suddenly going to make ones in it. I don't think I did this with you guys before. Well, what did I just say? No ones. Let me make this. It doesn't matter, Jeff. Just put a number down. There you go, buddy. All right. Now, it's not that big of a deal to multiply this one by maybe 8 and this one by 5, and then these would become 0, right? But still, if you have this big ass thing and there's like, let's even make this 51 and negative 89, right? I don't necessarily want to be multiplying both of them by 4 and 5. So here's the neat trick. What do you get if you multiply this first row by negative 2? Negative 8, negative 102, 2. Now, how the shit does that help me, Jeff? What are you doing, Jeff? What do you get when you add these together now?
You get 1.
You get a 1. So that general idea. I don't have to divide by 4 and get these ugly ass fractions. I can actually make it so that these become 1 when they add them together. So they don't kill each other when you add them together, but they make a 1. That is especially cool if you got this big thing, blah, blah, blah. What was it, 4, blah, 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 7, and you got even more stuff down, blah, blah, blah. If I can make that a 1, then I can kill all those 3, easy, right? And I can do it like we just did. If you don't get that, that's fine. There are other ways to proceed. Like I said, you could multiply this row by negative 9 and this row by 4. Those would make it 0, right? Because 0 is your ultimate, most important goal. But 1s are nice to have. So it's good to have other ways to make a 1. There's a specific problem where this actually sort of happens to you. I think it's in a 2 by 2 one.
It's a 3 by 3.
I call this, by the way, I'm going to do this every now and then. I call this a 2 by 2. This matrix is 2 by 3. The problem is 2 equations, 2 unknowns. So math people sometimes call that a 2 by 2. I'm not talking about how big the matrix is. I'm talking about 2 unknowns, 2 equations. Does that, in case I say that, and you're like, what the shit is he on? That's 3. Okay. Okay. Anything else before I move on and back into chapter 5 with the beautiful exponents that are so much better than matrices? That's somebody pointed out. Now listen, I'm not saying that from my own perspective. Matrices are flipping awesome. You just don't know enough about them yet to agree. All right. Nothing else? Okay. So let's get back into where we were. We go back to chapter 5 now. We had developed a few of the properties of powers. I think we, let's just summarize what we got so far. Let me see. I'm going to leave this on because we're going to use this green book in a minute. The first property, the most basic one, is if I have x to the 7th times x squared, x to the 9th. The chain to 7, link another chain of 2. Of course you got a chain to 9 now. There is no 7 in this whole thing. There's no 7 anywhere in there. This means that there are 7 x's. There's no 7s. Do you see what I'm saying? So don't say x to the 14th. You did 7 times 2. But there is no 7. There are 7 x's, 2 x's, so of course there's 9 x's. What about if I had x to the 7th divided by x squared?
X to the 5th.
Yeah, that'd be 7 minus 2, so that'd be x to the 5th, right? So Add when you multiply like bases, subtract when you divide like bases. So a little side note, what's this? I don't know what that is, Jim. Do you know why some people say the answer is 1? Because 5 divided by 5 is 1. How many 5s do I have, though, up here? I got 7 5s up here. And I've only got 3 5s down there. These 3 can't kill all those 7. Do you see what I'm saying? You can't say that this is 1 to the 7. No. 7 minus 3, so I got 4 5s left. So the base doesn't change when you do these things. The base doesn't change because it's the exponent that's keeping track of how many of those things there are. That's why the exponent is what changes. Okay, maybe. Okay. And then we got x to the 0 is, of course, 1. We got x to the negative 1 is... Uh-oh, do we forget? 1 over x. We proved it and talked about it in several different ways. Proof of it would be x cubed over x to the 4th. 3 minus 4 is negative 1. But another way to look at this is x over x. How many x's cancel? 3. How many are left? Where? There you go. So when you multiply by something with a negative power, you're going to lose x's, aren't you? What's another way to lose x's? Divide. That's all this is saying. Both of these ways, I'm going to lose an x. That's why negative power means it wants to be down. Flip it. So I got to be careful. It doesn't just want to be down. What would this be? 1 over b to the negative 1. Negative power means flip. So flip it. What do you get? You just get b. That 1b goes up. So wherever it is, it just wants to be on the other side. The long-ass way to do this problem is to say 1 over, well, b to the negative 1 is 1 over b. Oh my God. 1 divided by 1 over b is 1 times b over 1, and you finally get b. Do not do all this middle shit. Just say that b goes up, bam.
Does it say B to the 7 or B on it?
That's right. Okay. All right. I think that's where we left off.
Yeah.
All right, there's a few more properties. All right, I'm going to erase this here real quick. You guys got all this if you want it? So, what the hell is this? Actually, let me do this. Let me take this away. I'm doing 2 at once. Let's just so focus on this. There we go. What the hell is that by itself? X squared to the 4th power. What does the 4th power mean? Oh, yes, ma'am.
To me, it says you take x squared 4 times.
Yes. I mean, what's the fundamental idea behind the 4th power? It's that thing multiplying 4 times, right? So I could rewrite this as x squared times x squared times x squared times x squared. And then what property takes over? What do I do with the powers? Add them up. 2, 4, 6, 8. So what's the shortcut here? Yeah, multiply the powers. If I have 4 groups of 2 x's, isn't that how they define multiplication? You got 4 crates. Each crate has 2 apples in it. You know, that's how we define the multiplication, is counting of groups. When you first learn multiplication. 4 groups of 2 x's is 8 x's. Of course it is. Maybe. A long time ago, I tutored a cheerleader, and she came up with this. She said, when you multiply, you add. And she had other shit. This is all that stuck in my head. When you multiply, you add. Blah, blah, blah. Right? So when you raise, you multiply. Yeah, this is a higher thing. You raise, you multiply. I don't know. Just go ahead.
Oh, you just answered my question.
I really did? Were you going to ask about cheerleading?
Yeah, well, I was going to ask about the only. Did you ever coach a cheerleader? The only way you would multiply the exponents would be if they were on parentheses, correct?
If one's being raised to the other. I like it. So that's x to the 8th. So, for example, what would, how can I make that? Oh yeah, what would x to the negative 7th to the negative 2nd be? X to the 14th? Yeah. Because that says flip and that says flip. So together they don't do shit. It comes right back. So it kind of makes sense that the two flips, the two negatives cancel each other. A whole other reason why when you multiply two negatives, they cancel. If you flip and then flip again, you end up not doing shit. So the negatives just kill each other. So you get x to the 14th. Become a 14. Okay. All right. And remember, every property is because we chose to rewrite a string of multiplication in a more condensed form. That immediately led to all these properties. Just working with that condensed form, that's all these properties are. So now we'll do the one I had up here earlier, something like a cubed b to the 7th squared. Careful, what do you do when you raise something with a power to a power? You multiply. So a to the 6th, b to the 14th. Notice this is just like distribution, right? In fact, that's called power distribution. So exponents are based on multiplication. When they're working with multiplication, it's easy. Does somebody remember what you would do if you had this? I can't do what I just did. Because exponents are based on multiplication. What's inside? Shit. So it's going to be more difficult because you don't have things that work together. You'd have to write this twice, FOIL it. We're not there yet, but it's in our very near future. But that should sound vaguely familiar. You can't just go, square you, I'm done. No, because that operation does not work with powers. It doesn't. In fact, let me see. What if I had this? 2 times 3a plus 7b. Yeah, why is that so easy? Because coefficients are based on addition, aren't they? What's 2x really mean? X plus x. So if I have something based on addition, acting on something that is addition, it's going to be easy as shit, right? Maybe. Same thing up here. Look, that's based on multiplication. What's happening inside? Multiplication. Easy shit, right? Maybe. The minute I put plus in there, that goes to shit. That just goes away. And now I got to write it twice, FOIL it out. Oh my God, get a middle term right back. Okay. So let's try a few problems. Maybe I'll move to the
What
grid.
if you were dividing the two,
Oh, yeah. Okay. I'll do a part 2. So what if I had x to the 9th over y to the 11th cubed? Like that?
yeah.
Okay.
Would it, like, does the exponent do the same thing?
Totally.
Okay.
And I'm going to say something, I don't think I've told this to you before, but let's see if it freaks you out. There is no division. Division is multiplication. Because how you divide by something, you multiply by the reciprocal. There is no subtraction. There's only addition and adding the opposite of something else, right? So what is 5 minus 2? It's 5 plus negative 2. So what did I just say? Powers will act really nicely. It'll be easy if the thing on the inside is based on what they're based on, multiplication. Division is multiplication. Couldn't I bring this up? Make it y to the negative 11. Oh shit, then it's multiplication, ain't it? So division is, that's why they're the same level in order operations, because they're actually the same thing. I don't know if I blew your mind or if you are like, but does that make sense? That's what's most important. We know that you divide by multiplying by the reciprocal, therefore division is multiplication. That's it. So how does this work? This will be x to the, what is it?
27.
27 over y to the 33. Beautiful. Bodasical. Okay, so let's move into the green book so I can do some stuff out of there. So this is on, let's see, let's get somewhere interesting. Oh, here we go, perfect. Blah, blah, blah. Page 71. Real quick, up here. Help me out with this here. What is 15 to the 0 power? 1. If 15 to the 0 was 0, when I multiply it by something, the answer should be 0. What do I get when I multiply 15 to the 0 times 15 to the 1? What do I do with the powers? What's 0 plus 1? So I get 15 to the first. Is that 0? Therefore, 15 to the 0 cannot be 0. Because if it was, you would get 0 when you multiplied something by it. I actually get the same thing. What acts like that when I multiply? I get the same thing. 1. So that's another reason why 15 to the 0 is 1. Because it does the same stuff that 1 does. What about number 2? Careful. Anything to the 0 power is 1. So it can't be 0 because it doesn't act like 0. Anything to the 0 power is 1. This mess to the 0 power is 1. If you want to, we distribute. What's x to the 0? What's x to the 0? 1. Times what's y to the 0?
1.
So you get 1. All right, cool. Because was anything left out of being raised to the 0? Was there anything that wasn't? No, so everything becomes 1. So what's different about this guy?
Because of the coefficient.
What's on the 2? What power is understood to be up here? 1. So 2 stays 2 times, what does this guy do? Oh, crappity-doo-dah. What does this guy do? Turns into 1. So you get 2. Woohoo! Why is a 2 left alive? Because he wasn't being raised to a 0 power. He was over there by himself. Nothing happens to him. So what about number 4? Same idea. Careful. Anything to the 0 power is 1. And the 9 is just sitting there. Like, what's going on up there? I was thinking about fractions as somebody living under somebody else. What the shit are you guys doing? Shut up. I'm weird. All right, let me see. Blah, blah. We already know this stuff. Let me see real quick. What's number 3 down here? Z to the 99. Because what's the rule? When you divide like bases, you subtract the powers. Let me see if you guys can handle this shit. Ready? You're all like, whatever. X to the 2m over x to the m. X to the m. Because what do you do with the powers? Subtract them. Does that property say if the powers are whole numbers? No. Does the property say if the powers are numbers? No. It just says you subtract the powers when you divide like bases. So I don't give a shit what's up there. Right? So what about this? What about x to the a over x to the b? What is that? That's trying to be an a, by the way. X to the a minus b. The rule doesn't give a shit what's up there. It just cares that these are the same, the bases are the same, and I'm dividing. So it says subtract the powers. Whatever the hell they are. Oh, here's a yummy one. You ready? Number 5 down here. People always freak about this, but the trick to all of math is to break it into parts. If the problem was that, if the problem was this and you freaked out, I would ask you to leave. Right? If I said reduce 3 over 12, what do you get? 1/4. So see, I mean, that is a part of this problem. That part is easy. So that part becomes 1 over 4. Now look, how many x's cancel?
2.
How many are left?
1.
Where?
At the top.
How many y's cancel?
2. 4.
4 y's cancel. How many are left? 4 on the top. What, 8 minus 4 is? 4. And then z's, what happens to z's? Yeah, there's only going to be 1 left. I had 2. I divided 1 away, so now I got 1 left. I was trying to be a z. Still trying. So see what I did? I focused on the numbers, and then I did the letters as they came. So I chunked it into little easier problems. Students see this problem, they look at all of it, and you're like, holy shit. But if you force yourself to break it into parts, each part is not hard. Oh, what about this one? Number 4, I like 4. You would.
M to the first power.
Almost, except you just left the 3 out.
Oh.
So I have 5 3m's. Divide 4 3m's away, I'm left with how many 3m's?
3M.
Just 1. I'm left with 1 3m. Are the bases the same? Yes. What is the base? 3m. So since I'm talking about I've got a certain amount of 3m's, the answer is going to be a certain amount of 3m's. So the powers are keeping track of how many bases, how many 3m's I've got. Okay. Yes?
I'm sorry, how'd you get the Z4 on the number 5 again? How'd you get 4?
Oh, it's not Z4, it's just Z. It's y to the 4th.
Oh, sure.
Because you had 8 y's, divide 4 away, so now you got 4 y's left. I like it. I like it. Blah, 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 blah. Real quick, what would this be? This is the next page, 72. Yes. Sometimes I used to do this, and then I decided to stop because it's kind of evil. 4x squared y cubed z to the 5th divided by 8, x to the negative 7, y to the 10th, z to the 110.
1.
Yeah. I put it in bonus, to be honest, but I can put a bonus problem down. Like, just notice that it's to a 0 power. People started doing, okay, well, 1.5, subtract the power. Look. Yeah. So that's just 1. I don't care what's inside. It's being raised to a 0 power. Everything is being raised to a 0, so it's 1. What's this guy?
X to the 7th.
X to the 10th.
Yeah, 10.
How would you get x to the 7th? They would have to be... Get out of there. That would be x squared times x to the 5th. Then you would get x to the 7th. Right? 2 x's, 5 x's, 7 x's. This is 5 groups of 2 x's. That's 10 x's. Okay. Oh, what about this guy? What happens here? Well, then you're saying that only x is being raised to the 5th. What's being raised to the 5th power? 3 and x. So it would be 3 to the 5th, x to the 5th. The 5 goes and distributes to both. Because, again, what does 3x to the 5th mean? It means how many 3x's? 5 of them. 3, 4, 5. Oh my god. So then how many 3's do you end up with? 5. How many x's do you end up with? 5. So the shortcut is just distribute the 5. That's what's going to happen anyway. That's how we developed the original distribution rule. Okay. Let me see where things get more interesting. Ooh, yummy. Alright. What always saves your ass is order operations. Try to do number 3. This is page 73. Order of operations. So just to stop anybody short from doing the most basic mistake, are these the same base? So you can't say it's anything to the 7th. You can't combine them like that. They're not the same base. There's no condensing it then. So what would an order operation say to do first? Exponents, because I have exponents and I have multiplication. Well, exponents are before exponents are before multiplication. What's 2 cubed?
8.
8. 2 times 2 times 2. What's x squared cubed? What do you do with the powers? Multiply. So you get 6 times 4 3s. Oh shit. What's 3 times 3? 9. And you'll have another 3 times 3. 9. What's 9 times 9? 81. So 4 3s multiply to 81. 3 times 3 times 3 times 3. So you get 81 x to the 12. Coolness. What's 8 times 80? 8 times 8 is 64. 8 times 80 is 640. 8 times 1 is 8, so that's 648. X to the what? 18. Well, it's so going to suck until you get more used to it, right? 6 x's, another 12 x's makes 18 x's, of course. Right? You don't multiply 6 and 12 because you don't have something being raised. Right? So let me see if I say this, if any of you get this. Do you see how what I do is one off? So what I do when I multiply, I add. Isn't that like one step down?
Oh, yeah.
On the order operations? When I multiply like bases, I add the powers. Or divide, subtract. Still one step away. When I raise a power to a power, that's exponents, it's e, I multiply the power. So it's one step down on the order operations. Some of you guys are like, you just said a lot of words. And some of you guys actually kind of see what I'm saying. It's just a way of looking at it. If you don't like that way of looking at it, don't. Come up with some way to remember when to do what, though. Some of you guys are like, I'm always going to multiply. I'll be right about half the time. All right, whatever. Or no, don't do that. So what about this guy? What's negative 2 squared? 4. Why is it not negative 4?
Because it's 2 negative.
If you put this in your calculator, it will tell you negative 4 because you told it to do the wrong thing. You told it to square 2 and then put a negative on it. What does this say to do? Square negative 2. That's definitely going to come out positive. M squared is M squared. This is amazing. N to the 4th squared. So when you raise a power to a power, you multiply the power. So the other thing I get wrong is people say the answer is 16. What did somebody do if they say the answer to that is 16, n to the 16th? They did 4 squared. Doesn't make any sense because there's no 4 in there. Right? There's 2 groups of 4 n's. So of course there's 8 n's. Okay, I like it. These are just things, and they all go back to the basic definition. So yes, you do have to memorize it, but it also makes sense. So it's not just straight memorization of, these are the stupid rules I told me. No, they make complete sense. That's my hope. All right. Ooh, let's do one of these. Please tell me they got one. Well, sort of. Oh, they don't have any negative rules. That's why. There we go. Yeah, buddy. Now we're talking about it. Sorry, I gotta help them catch up to where we are. Here's some negative power stuff. This is page 76. Now let me say this the way there are 4 x's. Do they like where they are? No, so they're negative. They want to go the other side. So how do I rewrite this? They go up and it becomes x to the 4th. Now, sometimes I'll have people bring them up and still have a negative here. And then I'd be like, well, then they go down. And then they go up. And then they go down. And they never stop. Holy shit. So those 4x's do not like it down there. They're negative. Bring them up top. Now they're happy. I know it's kind of a Fisher-Price's way of saying, but it's a nice way to remember it. So what about this one? So it comes up, becomes 3 squared, which is 9. I like it.
So in that kind of situation, you would want us to, for an answer, the answer would be 9.
Yes. So if you get something that's like 4 to the 7th, don't do that. But if you get 4 squared, say 16. You know what I mean? So there's kind of a fine line in there somewhere. Like, what if it was 4 to the 4th, Jeff? I would have to say in the instructions, actually do it and give me a number, right? Okay. So here we go. Here's the ultimate problem. Page 77. There are multiple ways to do this, and I disagree very much with some of my colleagues about how to do this. There are a few times when we don't use order operations. This is not one of those times. I'd rather simplify the inside and forget the outside dude. Screw the outside dude. I'm going to do him last. It's a weird shit. I don't want to bring -3 in everywhere. That's just gross. Let me simplify the inside first. Now watch. Is everybody on the inside cool where they are? No. So the first thing I do in a problem like this is find the negative powers and move them. That way I'm not going to make negative mistakes because I'm going to get rid of all my negatives. Right? I'm going to do what they say. What does that y -2 say it wants to do? It wants to go down. When it goes down there, so these 2 y's go down. So now I got x. There's already a y squared there. And now those 2 y's come down also. So that's the one little thing I just did was anything to a negative power. I left a 2 off the x, didn't I? No, there he is. Anything to a negative power, move it. If it's on the bottom, move it up. If it's on the top, move it down. Now, analyze what you got. What can I do on the inside still? What about the x's? What happens? How many x's are left?
1.
Where? On the top, because that's where more of them were. How many y's do I have on the bottom now? 4. And I still got my -3. Good Lord, Jeff. Writing big is all shit. You can zoom out. Somebody semi-decent with that? The inside, I highly recommend you move everything with a negative power because that's what negative powers mean. And then when you put stuff together, there are no negatives to get in the way. It makes things so much easier and cleaner to see what's going on. This tells me to do 2 things. It tells me to, what's negative mean again? Flip. It tells me to flip it and then cube it. So what do you get when you flip that thing? When you flip this, what do you get?
1/3.
No.
Oh, wait. Oh.
All right, sorry. I'm not picking on you. This happens to everybody. This is -3. Is 3 being raised to a negative power? No. It's -3. It's not. It can't become 1/3. Only if it had a negative power on it, and that would be really freaky. Tiers of powers. We don't want to do that yet. That negative is acting on what? What's this power acting on? This. So what's going to flip this? What do you get when you flip this?
Oh, y12 over x.
Careful, we're not there yet. Let me catch up to you. So if you flip it, it's y to the 4th over x. What do I still have? I flipped it. What do I still have to do?
Oh, make it positive.
Cube it. So whenever you have a negative power on the very outside, look at it as 2 things. And do each thing one at a time. Flip it. Go ahead.
Why didn't the 4 change to a negative when you flip it?
Why is the 4 flipping? Because of this guy.
Oh, okay.
So this says flip these things. So the y4 goes up, the x goes down. If inside I just brought this up because I felt like it, then I'd have to put y to the -4 because where does he really want to be? On the bottom. But why is he up now? Because of this guy. This guy told him to flip. I really want that to make sense. Whatever has a negative power on it stays the same. It just moves to the other side. And now I cube everything. What do I get on the top? Y12. And what do I get on the bottom? X to the 3rd. Crazy shit. Yes, ma'am.
And you still, you can't reduce that.
No, yeah, because the bases aren't the same.
Okay.
I like it. Beautiful.
So then, even if you wouldn't have flipped it because of the negative exponent after you distributed it, it still would have had it.
Yeah. So, I mean, there are, let me see, there are multiple ways to do this problem. Watch. Let me just focus on the y's for a second, okay? What do you do when you divide? What do you do to the powers? Subtract. Negative 2 minus 2, negative 4. Do you see already, you're trying to do all this negative stuff in your head. And as a human being, it's easy to make a mistake with that shit. But negative 2 minus 2 is negative 4. So that would be y to the negative 4 inside, right? Forget about the x's for a second. They just left. Just focus on the y's for a second. Is that cool? So y negative 2 over y squared. Negative 2 minus 2 is negative 4. What is y negative 4 to the negative 3? Y 12. Yeah. So there are multiple ways to do this problem. If you don't like my way, if you'd rather just do it like that, using the properties directly and bringing all these extra negatives in, there's nothing wrong with that. It's just, I believe you're opening the door to make some simple mistakes because you're trying to do all these negative stuff in your head. I don't want to do that yet. Let me see. Oh, let's try this first problem out. That should be nice compared to what we just did. There's one little mistake people make with this. There's not much you can do with this. There's only a couple little things. Yeah, what are you flipping exactly? See, that's the problem. What exactly is being raised to negative power? That x and that z. That 2 is going to stay right where it is. I like it. So you rewrite this as, what stays on the top? Y squared. And what comes to the top now? Z squared. 2 stays on the bottom, and those 3 x's come down. So all that happened was these 3 x's, just look down here, Jeff. There you go. These 3 came down, these 2 z's came up. That's all that happened. That's all we can do. We don't have any like bases anywhere. Good so far. All right. So what I want to do for us today is I want to let us out very early. Let me say this, just to remind you guys.